Hi, everybody. It's Mr. Noah here. We're going to work on that. Guess I got a little guest. Say hi.
Hi.
My son. We're working on. See, we're learning too. He's in class. Well, I'm on the screen back there. You can't see me, but you can see him. He's on the. He's working on his schoolwork too, right?
Yeah.
All right. So I'm going to teach some of my friends here, and then you work on your schoolwork. Okay? You want to say anything to anybody?
I am wondering if
I bet
if
you
you
they like to play Minecraft. You like to play Minecraft?
Yeah.
You like to play Minecraft?
Yeah.
Tell them, what was your favorite Minecraft character?
My favorite Minecraft character, it's on YouTube. My favorite
What's his
Minecraft.
name?
His name is Preston Plays.
Oh, you like that? Yeah, he watches that guy. All right, you go get your schoolwork done.
Okay.
All right, and I'm going to teach these guys. Okay?
Bye.
All right. All right, I hope everybody had a good weekend. Okay, we're working on a brand new topic here. So today's assignment is to work through this worksheet. And I'll work through it with you. But today's assignment is to finish this worksheet and submit it. If you have not submitted last week's stuff, you could still submit it. Mr. Byrne and I will still take that. That's not a problem. Okay. The quiz, if you have not submitted the quiz from Friday, let's do that. Also, the school wanted to remind everybody that don't forget to sign on for attendance. Don't forget to go on Infinite Campus and take some attendance. Do your attendance today. That's really important. And also, don't forget to turn in your stuff because we're keeping track. We did hear from Harper. Remember, this class, you have to take the Harper final, and that's going to be at the beginning of May. And we're going to review for that after this chapter's over. So when this chapter's done, we're going to review the Harper final. And you got to take it. Remember, that's to get in. That's to do the Harper stuff. That's 15% of your grade. And be ready for that. Okay, so get all prepared for that. So let's go through this one now. Okay, let's take a look at this one. And this worksheet, like I said, you see it right there on Schoology. This is posted on Schoology. And you work through it. I'll work through it with you because the idea is we're looking at patterns. Okay? And then remember, we had linear patterns where the numbers went up the same. Okay? Take a look at this one. This goes up by 5. Oh, wait a minute. That goes up by 5. That goes up by 5. That goes up by 5. So now we can make a prediction that this one's going to be 27. You see? Because this type of the pattern is linear. That was the first type of pattern that we had. A linear pattern. Okay? Because, and how do we recognize a linear pattern? A linear pattern, the rate of change is the same. You see that? That's how we know we have a linear pattern. Okay? And people were pretty good with that. You're pretty good with that type. Let's look at the next one. Okay? Here we got the price. Same situation, same problem. Let's see the change here now. Always look at the change. 1. Now that went up by 3. So right away, we know that's not a linear pattern. Okay? Because that went up by 3. And this went up by 5. And that went up by 7. Oh, look. It's the odd numbers. The odds. Okay? When the pattern goes up by the odds, okay, remember we called that a quadratic. Okay, but that one we had to be really careful of because remember, it's all the odd numbers, but they could be multiples. For example, 2, 6, 10, 14. That could be the change. And remember, for the quadratic that looks like this, maybe we're on the downslope. So it's 7, it's down by 7. And then maybe it went, maybe 7 and 5 and 3 and 1. Maybe we're going down, but it's always the odds. And I can make them even by saying doubling it or multiply by 4, but that's the pattern. You see that? And so what's this must be? It must be change of 9. So this must be 26. And we called that a quadratic. And we did the quadratic formula, and that was all from last chapter. Okay, so let's look at this pattern now. This changes by 3. This changes here by 6. This changes here, oh look, by 12. This changes here by 24. Okay, notice, so it's not the odds. It's not the same. So this is a brand new pattern. Okay, and that's what this whole chapter is about. Got a brand new pattern here, and this pattern is called exponential. This is an exponential pattern right here. You see that? And an exponential pattern, take a look at this particular one. It doubles every time. It started at 3, and then it times 2 got me 6. Times 2 again got me 12. Times 2 again got me 24. Now, I'm not saying it's always times 2. It could be times 3. It could be times a half. But that change is what we're looking for. Okay, the change of the change. This keeps, there's your pattern, 3, 6, 12, 24. Okay, so we're going to do times 2 again. So this change is going to be changing by 48. So if it changes by 48, that's 96. Also, take a look at the numbers here. 3 doubles to 6, doubles to 12, doubles to 24, doubles to 48. You see what I mean? You see that doubling pattern. And I don't want to say, I'm not going to put in your mind that it's always doubling. It could be anything. Hey, Io's here. What's going on? You're in the wrong class there, buddy. This is, but I appreciate you here. Okay. So now, let's look at this. Okay. Take a look. Let's read through it. Okay, unit 3 was linear. That's what we're saying, unit 3. Unit 4, quadratic. So unit 5, we're doing exponential. Okay, so let's look at this pattern here. Okay, doubling. So started at 2, doubled to 4, doubled to 8, doubled to 16. Well, we can work our way backwards also. Instead of doubling, if you go backwards, we're dividing. Instead of multiplying by 2 times 2 times 2 times 2, we could divide by 2. 1 1/2. Here's where you need your calculator. 1/4. All right, let's put a decimal down here. If we could take our calculator, 0.25. 0.5. I'm going to need my calculator right here, and I'm working my way backwards. Okay, let's get back to the home screen. Take a look at the calculator. I was at 16, and I divide by 2 to get 8. Divide by 2 again to get 4. Divide by 2 again. Divide by 2 again. You see how the pattern's staying the same, whether we're multiplying or dividing. Divide by 2 again, we're at 0.5. Divide by 2 again. Divide by 2 again, we're at 0.125. Divide by 2 again, we're at 0.0625. You see what I mean? That's that pattern that we're looking at. Okay, we're looking at how it moves back and forth. And before, okay, here's a nice way of thinking about it too. If you look at linear, we're adding 5, adding 5, adding 5, adding 5. If you look at exponential, we're timesing by 2, timesing by 2. We're multiplying. So that's a good way to tell the difference. If it's adding or subtracting, then that's linear. If we're multiplying or dividing, that's exponential. So exponential changes by multiplying or dividing. That's how you move from one. So you try linear first. All right, up 1. Oh, that doesn't go up 1. So I know linear is done. So then we try multiplying. Times 2, times 2, times 2, times 2. Then that's exponential. Okay, what's the pattern given the output above? Well, if we're going down, the numbers are getting bigger, so as we go bigger, the pattern is times 2. As we go backwards, as we go smaller, it's divide by 2. You see how we could, depending on which way we want to go. As we get bigger, even this one. If I put on my calculator and I put in 0.0625 and I say times 2, there we go. I'm at the next one. Hey, he wanted to. If I go times 2 again, I'm at the next one. You see? So this direction is times 2. The other direction is dividing by 2. Okay? And we found the missing outputs. How the output values from 1 and -1 related. All right, let's take a look. Okay, let me make these as a fraction. if I go on my calculator and I go 0.125 and I remember math, fraction, if I make it a fraction, it says 1/8. So we put that down there, 1/8. And then I go 0.0625 math fraction, it says 1/16. All right, so how is -1 and 1 related to each other? 2, 1/2. How is 2 and -2 related to each other? 1/4. Let me change colors here. How is this one 4 and 1/4? Let me get another pen. Get a different color here. How is 8? So 3 and -3 related. Okay, can everybody see that? How are those related to each other? What's the word they're used? Anybody remember? They're reciprocals. Reciprocals, remember you flip them over? They're reciprocals. If I flip over 8, I got 1/8. If I flip over 16, I got 1/16. They're reciprocals. The negatives and positives are reciprocals of each other. And what is the output when the input's 0? Well, when the input's 0, the output's 1. 1. Let's do an example. This is how exponentials look. You see, you got a number to the top. Take a look at here. 2 to the x is equal to y. Not 2 times x. Make sure when you write it, that x looks like it's in the exponent. This is not, they put a not, 2x. Don't write it as 2x. That's not correct. Okay, 2 to the x. It's in the exponent. Okay, look at this problem. 1.5 to the d. Okay, where is that located on your calculator? The to the button is right here, above the divide. That's your to the button. Okay, so for example, if I want to type this in, if C of 12, I write it like this, 1.25, 1.5 to the 12th. Okay, so if I want to type that in, I type that in as 1.25. Don't forget the parentheses. Parentheses, 1.5, close parentheses. Always put the base in parentheses. Always put that number in parentheses. To the, and then I get a little exponent right there, 12th. Enter, and I get somewhere. You're going to have a lot of decimals. That's why you want to use your calculator on this. 162.18. Okay, let's see what this means. The cost of movie tickets has increased, there's our word, exponentially. Increased exponentially over decades. D is decades, since 1953. This is the function. Okay, what does this mean? So after 12 decades, okay, after 12 decades, let's see what 12 decades, a decade, remember, is 10 years. Okay, so 12 more years. So this says in, let's see what we got. 12 decades is 120 years. So if I go, I'm in 1950 and I add 120 years, so in 2073, everybody see what I did there? Decade is 10 years. So every 10 years. So when 1 is going to be 1963. 2 is going to be 1973. You see, it goes up that. So in that years, the cost, C represents the cost of a movie ticket will be $162.18. There's what we mean by content. You see how exponential grows really fast, really quickly. Okay? Fast and quick. That's what exponentials do. They don't go look at linear. Okay, take a look at linear, goes up pretty stable. Parabolas, okay, go up and down, don't forget. But exponential goes up very quickly. Okay, things grow exponentially. You see that? Change of 2, change of 4, change of 8. This particular one doubles every time. This one doesn't double every time. This one goes up by 1.5 every time. There's the number that we're looking at right there. Okay? Well, so what I want you to do is I want you to try this sheet. Okay, everybody try the sheet. I worked through it with you. I want you to everybody try this sheet and submit this sheet today. Okay? That'll be your grade for today, submitting the sheet. Don't forget last week if you still need to submit. Okay? A lot of people, no, there's a good number of people have been turning stuff in, so I appreciate that. Okay? But we still need a few more people to turn in the quiz, and we need more people to turn in day 2, day 3, day 4. And all those words out the review sheet that we passed out before you left, but also the review sheet we've been posting online. So that is your assignment. Make sure you turn those in. Okay, and hopefully everybody have a good day.